And I think we were talking about the spatial phase last time. And if you remember, let me have a small discussion on that before going forward. It's like if you have two waves, so I'm fixing time here. I'm fixing time and then I'm looking at two different waves at the same time. Then let's say what will be the plot? Y versus X का plot रहेगा. Yes. Good. Y versus X का plot. And how will the graph look like? Let's say one of the graph is something like this, and the other graph is something like this. I am taking two different waves at the same time and they're trying to say. So it's something like I don't remember if I said it like that or not, but maybe you can imagine two people who are racing. One of them is a little behind than the other, and they both move with the same speed in the same direction. Then there will always be some kind of distance between the two, na? Because the one of the person started a little behind. Yes or no? But if I were to magically place that guy with the same person, then they will go together. Yes. So I am shifting that guy to this. I am shifting the whole thing. You can imagine as if I were to shift this wave by a distance x, if I shift the wave, then they both come in sync. Yes. If they both come in sync, then they will move together. So by how much distance is this wave 2 behind the wave 1? By distance x. Yes. And in terms of angle, if I want to say, then I say by an angle of phi it is behind. So what will be the equation here? A sin kx minus omega t. This can be a sin kx minus omega t plus phi. And then how we used to imagine this? If only I subtract this phi, then both the waves will look together. Yes. And how will I subtract it? By shifting this. Yes. And then I said if I shift by x position, my angle phi is shifted. Then if I shift by 1 lambda position, then how much angle? You traverse 2 pi radians. Again, this I told you last time. That if you go from one position to another position by lambda distance, then how much angle are you shifting? 2 pi radians. Then if you were to shift by x distance, then how much angle? Let's say phi. And this is maybe what you do in chemistry stoichiometry somewhere. You cross multiply, na? And then you say lambda into phi is 2 pi x. And then what is phi? 2 pi by lambda into this. This is phi s. What did I compare here? When I did this discussion, what am I comparing? I'm comparing two waves at the same time. Two waves at the same time, and this is the phase difference between those two waves. Okay? For a given x, for a shift in x. What if I consider the same wave and two different particles? Let's say I have a wave like this. I am fixing time. Please remember, fix time. Let's say I have a wave like this. At some position x1 there is a particle. At some position x2 there is another particle. For position x1 it traverses an angle phi1. For position x2 it traverses some angle phi2. Then what is the phi2? The phi2 is 2 pi x2 by lambda. Phi1 is 2 pi x1 by lambda. Then what is the difference in angles between them? That's phi2 minus phi1. And I can take 2 pi by lambda common. I will get 2 pi by lambda x2 minus x1. And what is this equal to then? That's delta phi s. That's equal to 2 pi by lambda delta x. What is this called now? This is the phase difference between what? Between two particles of the same wave at a given fixed time. Are you understanding? Here, what is this phase difference?
Between two
different waves. This is between two different particles. Do you understand the difference? Yes. So, this is the phase difference. Please write with me. Phase difference, the spatial phase difference between two particles of same wave. What is this delta x called? That's called the path difference. How far away is one particle compared to the other? So if this is x1, this is x2, then this is delta x. Does it make sense? This is with respect to spatial. Why is the attendance so low today in this class? Achha, most of them are in that. Oh, highly wala. Okay. This was the discussion on spatial phase. Anything that you want to ask here? Did you understand everything? When we were talking about spatial phase, we were talking what is a shift in x and fixing t. Now when I talk about temporal phase, what will I shift? Shift in t and fix what? When I fix x, then which part? I am looking at only one particle for a given x, for a given position of space. I am looking at one particle, and then I see its time evolution. How will the time evolution look like? So temporal phase. What will you fix here? Fix x. When I fix x, then what am I doing? Looking at one particle. Studying one particle at position x. Is it okay? I'm studying only one particle, its time evolution. And what will the time? It's an oscillatory motion, na? The particle oscillates. So how will the time evolution look like? Achha, before I was making a y versus x graph. Now I will make y versus t graph this time. I will make a y versus t graph. X. Can you anticipate how the motion will look like? It's an oscillatory motion, no? Oscillatory motion maybe it's a periodic motion. Then maybe the motion will look like this. Yes. Good. Now if I consider that, so this x-axis is time, huh? So this is the displacement of the same particle at different times. This is what I have plotted. Does it make sense? I'm talking about only one single particle, uska time evolution. Then at some time t1, let's say the particle, the displacement was y1. It has a phase phi1 at some time t1. At some time t2, it has a phase phi2. Okay. Achha, by the way, in the spatial phase, I was talking about the one wavelength corresponds to 2 pi radians. In time, what can I say then? In terms of time, what is time for one wavelength? That's called time period, na? So one time period corresponds to 2 pi radians. Does it make sense? Once you come back to the original position. So one time period corresponds to 2 pi radians. Then some time period, some time t, at some time t, what will be the phase? That will be phi. And then phi into capital T is 2 pi t. And then phi t is equal to 2 pi by capital T into small t. What is this phase? At some time t. At some time t, this is the phase. Then what will be phi 2 minus phi 1? At some different times, t2 minus t1 होगा, and this will be what? Delta phi t 2 pi by t delta t. What is this phase difference now? This is the phase difference between the same particle at different times. है ना? Same particle at different times. What was this phase difference? Different particles at the same time. What was this phase difference? Different waves at the same time. Please understand every one of them. They are very important. Do you understand the difference? Good. So this is delta phi t. So have you read it? Come on, do it a little fast. You have to do many things. Is it done? What is capital T? That's the time period. Everyone knows that? Great. Now let me ask you this question. I don't remember if I asked you this yesterday or not. What is the difference between I asked this? Let me ask you now, what did we find the thing to be? What is the difference?
Pi radian.
Phase difference pi. And then I said this is omega t, this is kx minus omega t plus pi. Correct, huh? So that's a phase difference, huh? Which phase difference? I have talked about so many phases now. Which phase difference is that pi? First one. What were you fixing in first one?
Two different waves at the same time.
How many of you say that is the first one? Any other opinions? This pi, what is our phase difference? Temporal, spatial, or maybe some other? So some people are saying spatial. What about the others? Come on, it's a very simple question. Let's see. Let's call it phi 1 and let's call it phi 2. Then what is the phase difference between them? That's delta phi. That's phi 1 minus phi 2, or maybe phi 2 minus phi 1, let's say. That will be kx minus omega t plus pi minus kx minus omega t. Now you tell me the phase difference has to be pi. That means these terms must cancel each other. When will they cancel each other? When I am talking about the same wave at the same position. So I am fixing x, but then the omega t's must cancel as well. That means what I am fixing now? I am fixing time as well. So I am fixing both of the variables. Only then you will get this. So what is this phase now? It's neither temporal nor spatial. What is this phase? If you only revise, you will know what phase this is. I have talked about this. Go back into your notes and tell me which phase is this. Come on, nobody will tell. What is that phase called?
Initial phase.
It's the initial phase. Very good. At t equal to 0 and x equal to 0, you already have an inbuilt phase. Do you understand? It's not due to any kind of spatial or temporal changes. It's called the initial phase difference. Simple as that. Let's do some questions now. Achha, before that, I have to talk about this relation between wave velocity, particle velocity, and acceleration. Did I talk about that? I did not. Relation between wave velocity, particle velocity, and acceleration. Okay. Let's take a general wave, a sinusoidal wave, a sine kx minus omega t plus phi, some general wave. Yes, what is del y by del t of this? Can somebody tell me? Del y by del t?
Minus omega is
That's minus omega a cos kx minus omega t plus phi. What about del y by del x? What del y by del x?
k cos kx.
Very good. It should be ka cos kx minus omega t plus phi. That's del y by del x. Let's take what is velocity of the wave? Can somebody tell me? Velocity of the wave? That's minus the coefficient of time divided by coefficient of x. What is that here?
Omega by k.
Is it omega by k? Correct? Now let's take the ratio of del y by del t and del y by del x, and what will you get? If I take this ratio, can you see that the cos cancels, the a's cancels, and then what will you get? Minus omega by k. What is this equal to? Minus p. But what is del y by del t? What is del y by del t? What is that called? Velocity of the particle. So you get a relation between Vp and V then. So Vp is minus V del y by del x. Actually, the first derivative represents what in a graph? The first derivative in a graph, what is it? It represents a slope. Slope of what graph? What versus what? Y versus x. So if I have a y versus x graph and slope, then the relation is minus v into slope of y versus x. Hopefully you are writing with me and going forward. Huh? This is the relation between Vp and V. Yes? Now let's try to find a relation between acceleration and other things. Then what is acceleration of the particle defined to be? That's del 2y by del t2 now. We take the second derivative. So can you tell me the second derivative value? Can you just by looking at it, can you tell me what is the second derivative value? Come on, you can do it in your head. So it will be plus omega square a. How many of you say it's plus omega square a? Others, check. Check if it is plus or not. Why did you not decide?
Because differentiation of cos is minus sign, that's 1 minus, and then omega is again minus again.
Correct. There will be 3 minus. There's already 1 minus. Cos ka derivative is negative sign, and then there will be a minus omega again. So you will get minus omega square a sine a minus omega t plus phi. Yes. What is y? What was y? That's a sine ax minus omega t plus phi. let's take the ratio of the, actually this is AP now. That's AP. Let's take the ratio of AP divided by y, and what will you get? I think sine will cancel again, and AA also cancels, and then what do you have in the RHS?
Minus omega.
So your AP is equal to minus omega square y. That means your AP is proportional to minus of y. What motion has this characteristic property? That's called an SHL. So the particle not only oscillates, it actually performs SHL. Yes or no? So the particle performs SHL. By using the wave equation, we found this. By using the wave equation. So, particle. Please remember SHL. That in general oscillations and SHM are not same. Remember this, huh? There's a difference. There's a very interesting property of A should be minus proportional to minus of displacement. Only then it's an SHM. Only then can you say. Good. Achha, if it is an SHM, then what will be the expression of velocity? What was the expression of velocity for SHM? Nobody remembers.
A omega minus omega
Vt should be equal to plus or minus omega under root of a square minus y square or x square?
Y square.
Where is the displacement?
Y.
Y square. Should be y square. Where is the particle oscillating? The particle oscillates like this. So y displacement. You remember this expression? Yes. This is the particle velocity. Again, another expression. Is it all okay? Good. Let me talk about the directions of DT and AT. Is it written up there? Or should I wait 1 minute? Clear, sir? Great. Then let's see. Let's say you have a graph like this. Achha, when you make y versus x graph, then what will you fix? Fix time. Let's say you're fixing time. Then you have a graph like this, let's say. Okay. At this point, can you tell me what is the direction of velocity? Let's say the velocity of the wave is along this direction. It's along the positive direction. And how are the positive? Achha, when you are fixing time, then it's a snapshot. Nah? It's a picture of any given time. And the particles were oscillating like what? Can you imagine how the particles were oscillating? They were oscillating like this. Yeah? What about here? Something like this. This is how the particles are oscillating, and at a given snapshot, this is the other particle is here, this is here, and this is here, and they were oscillating. Okay? Now I am asking you, can you tell me at this point, what should be the direction of velocity?
Upwards.
Will it be upwards? Can you tell me the slope? The slope of y versus x graph, is it positive or negative? It's positive at this point. Huh? What was the velocity expression? Minus VA slope. Slope of y versus x graph. What is the slope here?
Positive.
Positive. What is the v ka direction? Positive. Positive into positive. And then there is a negative. So where should the VP be? Upar ya niche? Niche. So it should be here somewhere. This is my VP direction. What about the acceleration direction? Can somebody tell me about the acceleration direction? What is the acceleration given to me? Minus omega square y. Wherever is the displacement, acceleration should be opposite to that. Where is the displacement? Up. Where is the acceleration? Down. So you have an acceleration down. Now let's do the same exercise here. Tell me for this point. Where will the V be?
Sound.
Niche? Some people are saying up, some people are saying down. Batao. What is the slope here? Slope is negative. So this is a negative value, negative into negative, positive. V is always positive, no? So what will be the VP? Up. It should be up. What about the AP? What about the AP? It will still be down because the oscillation is still happening upwards. Yes or no? So what will we do? अच्छा चलो जल्दी से अब बताओ इधर का VP और इधर का VP. इधर VP क्या है?
Upwards.
It will be upwards.
Upwards.
सोच के बताओ.
Upwards.
Slope ऐसे.
Negative slope upwards.
What about here?
Downwards.
Everyone agrees that this should be correct. Huh? What about the acceleration here?
Upwards is what it is.
It will be upwards. And what about here?
Upwards.
Again upwards. That's not right. So please be very careful about the directions of AP and V. Does it make sense to you? Whatever I taught. Okay. Write the whole thing and then we will go forward. Is that pink color visible to everyone? Yes. Yellow ke saath mixing. So, I should have written one more thing before going into this. Right? No. That what was delta phi by the delta phi of x? Or that's 2 pi by lambda into delta x. Huh? If let's say the delta x is lambda by 2, then what will be the delta phi? Bolo? Pi. If delta x is equal to lambda by 2, then delta phi is equal to pi radians. But can you visualize what is happening? Can you visualize? Can you tell me by diagram something like this, huh? Y versus x. Fixed T. You have 2 points. Let's say this point, and what is the other point? Lambda by 2 कहाँ है? यहाँ पर ये यहाँ.
Second.
ये वाला? This is the lambda by 2. How much angle do I have to traverse to go from here to there? Pi radians. So that you found, right? So don't just go for the formulas. Try to also visualize what is happening. How much angle do you have to traverse so that you come together? That is the phase difference. Acha, will this and this have the same lambda by 2 wavelength? Yes, sorry. Path difference? This is lambda by 2 kya? बताओ.
Yes.
That is also lambda by 2 ना? इनके बीच में क्या है phase difference? Can you imagine? 90?
90.
फिर 90. तो कितना हो जाएगा? 180. Does it make sense? So also try to visualize when you are writing out phases and all those things. So when two particles are have phase difference pi radians if they are said to be out of phase. If phase difference between two particles is pi radians, then they are out of phase by pi radians. Actually, if you have a phase difference of pi by 2, pi by 4, they are still out of phase, but by that much amount of angle. Pi by 4 clear, then they will be out of phase by pi by 4 radius. When will they be in phase? What do you mean by in phase?
When the phase difference is zero.
When phase difference is 0, what about, is there any other possibility?
Yes, when phase difference is zero.
2 pi, 4 pi, 6 pi, 8 pi, yes or no? At all those points, there is no phase difference between those two points. Huh? So if, and what will be wavelength? Acha, if phase difference is 2 and pi, where what is n? 0 plus or minus 1 plus or minus 2, so on. Then what will be the case? Then the particles are said to be in phase. This is the terms. So please remember the term. Out of phase, in phase. I should have talked about this before that relation, but what more things do I have to? Now I have to give a question now. So, can I write the question then? Yes? Let's do the question. Is that written? Or should I wait some time? 2 minutes. Okay, I'm waiting. What do you want this bag to cuddle? Yes. समझ आ रहा है? आगे बढ़ जाए? हो गया? तो क्वेश्चन ले रहा था इसमें मोबाइल अच्छा ये सुनना जेब में लेके मोबाइल दूर रखो And giving you 3 minutes, then I will start. Attempt. Yeah. Any answers for VP Max and AP Max? Chalo, if you feel like your questions are not enough, let me give you some more questions.
Sir, VP max 20 pass 40 minus 0.02.
Yeah, 20. VP max is 20. This is a function. I want the value.
20 sin 0.1.
Then sin 0.1. कुछ भी.
Variance.
Incorrect. अरे, the particle performs SHL. What is the V max of SHL? लगाओ. उससे और ये आंसर सेम आना चाहिए. लागू करेगा लागू. Any answers? 20 hertz.
Meter per second.
तो बोलो ना पूरा आंसर बोलो 20 मीटर पर सेकंड करेक्ट है. It should be plus or minus 20 meter per second. What about AP max? AP max. Come on, it's such a simple question. Should I start with the question?
20 meter per second.
Should I start or should I wait? I will wait one more minute and then I will start. Anybody give me the value of phase difference? Question करो बेटा. Did he find that over here? Maybe 5 omega. I don't know. Ah, it is 5 omega. But what is the value of omega? Very good.
My 20 is
Huh?
20.
Plus or minus 20.
It should be math. Okay, it's there.
क्या कर रहे हो? Wishful thinking. Try करो खुद से. Try.
Sir, acceleration minus 400 meters.
400. ये तो बहुत गलत बोल दिया बेटा. तुम लोग अभी एक्सेलरेशन ही करते थे तो पता नहीं कितना साफ करोगे. What is y? अच्छा, let's find these simple things first. What is the a? That's 5 meters. What is lambda? So what is k? That's 0.02 and that's equal to 2 pi by lambda. Then what is lambda? That's pi divided by 0.01 and that will be 100 pi. 100 pi meters. What is f? What is f? What is omega? 4. Omega t. Compare with omega t. Na? So what will be f? That's 2 pi f. So f will be 2 by 5 hertz. Yes or no? What will be the time period then?
5 by 2.
That is 1 by f. So that will be 5 by 2 seconds. We found everything. Simple things. Now what will be Vp max? So the particle performs an SHM. Na? See, if you really want, you can differentiate with respect to time and then say where will the maximum be. It's very simple. The amplitude will be the maximum value. Do you want me to differentiate or do you want me to use the direct formula? Bata? Formula is very simple. Since the particle performs SHM, so Vp is going to be plus or minus omega under root of a square minus y square. What will be Vp max? Plus or minus omega a. Yes? And what is omega? So that's 4. What is a? 5 meter per second. What is AP? That is minus omega square y. Where will the AP max be? When the displacement is its maximum. That's amplitude, na? So AP max, I think you have done these things in SHM na? Previous year. Minus omega square a. And what will you get then? Minus 16 into y a. A is 5. Something like that. So I found my Vp max, AP max, all those things. Now they are asking to find a phase difference. Should I give you 2 more minutes for phase difference? I need some answers from you. Can you try and find a phase difference of at least A? 2 minutes और रुक जाओ, A करो. Everyone knows these formulas, and they know how to compare. Omega कैसा है, A कैसे है, समझा ना? कुछ उसका प्रॉब्लम नहीं है. Do you understand? How I wrote it?
So it's phase difference of 1.4.
First one the 4 degrees. Seconds, 4 seconds. Phase difference. Radians.
Sir, options में तो ऐसे कि ABCD होता है.
अच्छा. और उसमें 4 radians, 4 seconds, 4 hertz सब लिख दिया था.
इसे नहीं आता है.
मैं दे देता हूँ इस ऑप्शन. यूनिट्स नहीं आता तो फिर फिजिक्स में क्या करोगे बेटा?
Phase difference.
अरे फेज डिफरेंस इज एन एंगल.
4 degrees.
But we do everything with radians. कुछ आया बोलो 400 radians 4 radians सर सेकंड वाले का बताओ फिर तो मुझे A पार्ट निकालना है अच्छा which phase difference they are talking about by the way they are talking about temporal phase difference huh? What was the formula of temporal phase difference that's 2 pi by capital T into small t but what is capital T
सर that is delta phi t on the x sir
क्या बोला
वो delta phi t ही है ना सर
हाँ इतना पीछे जाके बैठोगे तो बेटा क्या ही समझोगे
सर
4 delta t I think delta t is given to be 1 second so this is going to be 4 radians
next one 0.2
0.2
radian 1 by 5
ये जो 0.2 नहीं है ऐसे 0.02 होना चाहिए b करते हैं next one is which phase difference
Spacious.
it should be spatial and what is the spatial का formula
2 pi by lambda into
2 pi by lambda into delta x what is delta x given to be 10 what is the wavelength of the wave 100 pi so 2 pi
By 5 radians.
over 100 pi to 10 what will this be pi गया ये गया 2 by 10 अच्छा 0.2 ही इसका 0.2 सही अब मीटर लिख दिया should be radius बच्चों का एक्सपीरियंस हो रहा है मेरे को should be radius is it correct then let me give you a very simple question again as a homework so try this one as a homework y is equal to 0.02 sin plus t upon 0.02 find so it's a very simple thing. Is it written? जल्दी जल्दी करो. I want to do this discussion on waves.
Cos 34 minus 0.8.
what is another bit down
जल्दी जल्दी करो. बोलो. Can I go forward? Don't attempt the question right now. Let's write the question. Homework question है ये. ठीक है. Wave speed. if I have, let's say, two sources of sound wave, let's talk about sound wave. Achha, please remember, all the discussions that I am doing right now, these are all for mechanical waves, huh? Mechanical waves, not for light, not for electromagnetic waves. We are not talking about that right now. We will have a discussion on electromagnetic waves or light at least in wave optics later. Right now we are talking about mechanical waves, sound and all those things. Okay? If I have two sources of sound, let's say two speakers, one of them gives off a female voice and male voice, and it won't be the same frequency, na? Yes? One of them is a little frequency में क्या होता है? Loudness से नहीं pitch. हाँ, pitch से related रहता है शायद से. So the pitches will be different, I think. So, but they are moving with through the same medium. That means the waves will move with the same speed. So the waves are moving with the same speed, but their frequencies are different. If their frequencies are different, then their wavelength will be different as well. Because what was V? V was equal to F lambda. In general, for any kind of wave this follows, then if V is going to be the same for both the sources, and if F1 is greater than F2, then can you comment on lambda 1 and lambda 2?
Lambda 2
So I have a source S1, source S2, यहाँ से waves आ रही है, sound waves, ठीक है चलो. For simplicity, I am talking about sound waves. This is going with velocity v1, this is velocity v2, frequency f1, lambda 1, frequency f2, lambda 2. What are the relations? That v1 is equal to v2, that's the speed of sound. But f1 is greater than f2. Then what will be the relation between lambda 1 and lambda 2?
Lambda 2 is greater than
Lambda 2 is greater than lambda 1. So if the sound waves are going through the same medium, and if one of them has a bigger frequency, then it has a lower wavelength. Then I can make a relation that f max, if I talk about the maximum frequency, that will correspond to what? That will correspond to minimum wavelength. Inverse relationship, na? And f mid is equal to V by lambda max. In general, f is inversely proportional to lambda for a given medium. Acha, when you go from one medium to other, then what do you find for light rays, light waves? That the velocity changed. Here I am considering velocity to be a constant, na? It is constant for one given medium, but when the light rays goes from one to another medium, velocity even that changes. So I can't make such a statement there. So I am talking about only one medium here. Is it okay? So copy this and then we will go forward.
That's for the same medium, this statement also holds true for light, right?
For same,
For same medium.
बोलो for same medium. If I take,
if we consider light rays, for the same medium, the statement holds true for light also. Until we don't change the medium.
we are actually nearing towards the end of the chapter now. It's small, but there are so many small chapters that we have to cover a little fast. There is a superposition chapter as well, and now sound waves ka bhi aayega. So I will talk only for one case for transverse waves. So what we will do now is we will study what if a wave passes through different mediums. How will the velocity get affected? Okay? Here we picked only one medium. What if we change the medium? What will happen? And then there will be two categories. We'll try to understand for transverse separately and for longitudinal separately. So let me give the discussion on transverse wave. Okay? Acha, for transverse waves I am only considering for solids. So let's take the discussion. Wave velocities in different mediums. transverse waves in stretch string. Stretch rope. And the rope is basically a solid now. A solid medium. How will the rope, the transverse waves go, and what will be its velocity? We will try to derive that. Okay? So when you give a jerk like this to the rope starts moving like this. Yes. Okay. Let's consider a very small section of the rope. Let's consider the rope to be like this. ये कोई एक वेव का एक पार्ट लिया है, ठीक है? Let's consider this to be approximately delta L. ठीक है? This is like this, huh? Rope is something like this, and the wave is moving in this direction with some velocity v. That is the wave velocity, no? Wave velocity. If you consider, then this can be completed to a circle now, with some center O and some radius R. Okay? It will all make sense in a moment. For solving the problem, trying to find what is V, we will actually not consider the wave ka movement at all. We will consider the rope ka movement. Let's consider an observer which is moving with the same velocity as the velocity of the wave, and somewhere here there's a person here, person B. It's a reference frame with same velocity as wave. That means what is Vp? Vp is also V. Does it make sense? And now, rather than studying the wave motion, we will try to concentrate on the rope motion. Then rope motion. So, can you tell me what will be the velocity of the rope with respect to this observer? Can somebody tell me? What will be the velocity of wave with respect to this observer? By the way? Zero. What will be the velocity of rope with respect to that observer?
VRP.
So, what is VRP? So VRP, that's the velocity of rope with respect to P, is VR minus Vp. But in actuality, is the rope moving? The rope never moves. It oscillates, but it never moves. So this is 0. So then what is Vp?
V.
That's V. So what is VRP? So then with respect to this observer, it looks as if the rope is moving in the opposite direction with the velocity v. VRP is equal to minus V. Does it make sense? With respect to the person B. Now let's try to understand the motion. So let me make the diagram again. And this is my O. Achha, for this, the rope, there will be two tensions acting away from the rope now. If I take this to be my element, delta L, this is a tension T, this will be a tension T, and let's say this is my horizontal. This is my R. Let's take the angle, this will be theta. This is some other theta. The same theta, symmetrically considered. Achha, what is this? This angle is 90 degrees, this is also 90 degrees. Can you imagine that when the particle is so, instead of particle, so this element of the rope is moving in this direction with some velocity v. Then can you imagine it looks as if it is performing a circular motion on that arc? On that arc it's performing a circular motion. Then there should be a force which is acting towards the center of the circle, that is providing the centripetal acceleration. What will that force be? I have to break this tensions into two components. Can somebody tell me what will be this angle? What will be that angle? If this is theta, then what is that angle? should be theta or 90 minus theta? Theta. How many of you agree it should be theta?
Alternate.
See, this is theta. Then I think, not here, but rather, what will be this? This will be 90 minus theta? Yes or no? The whole thing is 90. Then this should be theta. Yes or no? If that is theta, then this is theta. Okay? So this is also theta. Okay? Then what components add and what components subtract?
Sine components add up and cos components.
Cos components cancel? Yes. So the sine components will act towards what?
Center of
They will act towards the center of the circle. So the cos components cancel and sine components is 2t sine theta is equal to mv square by r. Na? Yes or no? That is the centripetal force. What is that v, by the way? What does that v represent?
VRP.
What is that v in context of circular motion? That's the tangential velocity. And tangential velocity is actually, it acts like that. Na? So that is the tangential velocity. Acha, I am going to consider a very small element of delta L. That means the sine theta is also very small. Then it can be approximated to theta. Since theta is small, so sine theta is approximately theta. Now what about that m? Let me define a mass per unit length quantity mu. That's mass per unit length. Linear mass density बोलते हो ना तुम लोग इसको? Linear mass density. Then what is that? That's mu L. Then what is the mass of this whole row? What is the length of this? Can somebody tell me? What is that length?
R 2 theta. 2 R
2 r theta होना चाहिए ना? So mu into 2 r theta. Everybody agrees that that should be 2 r theta length, the arc length. Yes. So what is m then? So let me write everything. So it should be 2t theta should be equal to v square by r mu 2 r theta. Some things cancel. 2 गया, theta गया, r आ गया. Then what do you get? You get that v is under root of t by v. And what was this v? Do you remember what was that v represented? That's the velocity of the wave. Yes, sir. Magnitude wise, that was the velocity of the wave. So when a wave travels through a rope having some mu and some tension t, the velocity is given to be under root t by. You should write this. Of a wave traveling on a rope. Everyone has written up until here?
No, sir.
You want to start from here?
We would still be able to do the calculation. We would still be able to do the calculation if we don't take that result called rate.
Obviously, that's just for simplicity. That we are not considering the wave commotion but rather rope commotion. And anyways, we found the final answer. क्या नाम है बेटा तुम्हारा? पूरा नाम? अरे चौधरी। नाम बोलो नाम। फर्स्ट पेज। गणेश राम। चलो। बोलो So we found the velocity of a transverse wave going through a solid. Now we will not talk about the fluids, but rather we will go to longitudinal wave and talk about its velocity in other things. So is it written? It will be a small discussion, but jaldi I will basically give you formulas. I will not do any derivations there. Stop. Velocity तो obviously बढ़ गया, ठीक है. It may even experience phase में changes. I told you maybe when we were talking about that, when light refracts, then something happens, the velocity changes, but there is something called as phase kickback. Phase में बीच में जाता है, वो भी होता है. फिर उसका wavelength भी बदल सकता है. ठीक है, करेंगे डिस्कशन सबके ऊपर करेंगे. Frequency नहीं चाहिए. And I will have to look for mechanical waves whether it will change or not. Electromagnetic में तो नहीं होता. Is it done? So let's talk about the speed of a longitudinal wave through different mediums. So basically, I will give you a direct formula for every one of them. For fluids, the formula is given to be V as under root B by rho. Where what is B? That's called the bulk modulus. Have you heard about bulk modulus in elasticity? B is the bulk modulus, and rho is the density of the medium. When I talk about fluids, I am basically talking about liquids and gases both. Na? This is the formula that Newton gave actually. This
So what is the what is it B equals to?
Under root B by rho.
B by
और 4 किलोमीटर पीछे जाके इधर बैठ सकते थे ना फर्स्ट बेंच पे आके. नहीं, एकदम लास्ट बेंच पे जाके बैठना है. Under root B by rho, ठीक है. This was given by Newton, and what he assumed is that if a sound wave is a longitudinal wave, then when it passes through air, then he assumed it to be an isothermal process. And by isothermal process, what do I mean? that as the sound wave goes, it does not change the temperature of the medium. This is what he assumes. And obviously, as the sound wave is going, what was B defined to be by the way? What is the definition of B? Anybody remembers the formula? What is B equal to? Wow. A revelation. He told me B is bulk modulus. Did you know that? What is B defined to be? I think V by delta V or delta V by V, I don't remember. Maybe delta V by V. ये check करना है इसका. I don't remember exactly. This change in volume divided by change in volume divided by original volume into the pressure of the medium. That's how we define the bulk modulus. But when the sound is going through a medium, it does not change the volume of that thing. So that means this thing is going to be ये one other answer. So B can be replaced with minus V. So let me write the final thing. P is equal to P by rho. If I considering motion of sound waves through air is an isothermal process. This is the velocity of the sound. No, this is in general the velocity of a longitudinal wave. But if you consider for sound, then what Newton found, these are all formulas given by Newton. And Newton found that the velocity was coming out to be something like 280 meters per second. If I consider it to be an isothermal process. And that's not good because the usual speed of sound is 330 meters per second. So this is off by a lot. And then Laplace came after maybe 50-60 years, and Laplace gave a correction factor. And he said that the speed, that as the sound wave moves through the air, is not really an isothermal process, it's an adiabatic process. Do you remember what was the definition of an adiabatic process?
Heat exchange is zero.
There is no change in heat, but all fast processes are also called adiabatic. Do you know this? All processes that are fast are adiabatic. All processes that are extremely slow, they come under the category of isothermal processes, at least in thermodynamics. And the speed of sound, the sound motion through air is a very fast process. So it's an adiabatic process. This is what Laplace said, and Laplace gave the correction factor. Laplace's correction is that velocity should be gamma v by rho. Considering motion of sound waves through air to be fast enough to be called as adiabatic. When you consider, I am not going into the derivation of it, there is a derivation of this correction factor, but let's leave it. This gamma is called the Laplace correction factor. Okay? Laplace correction factor, and you can just remember for air, if the thing is going through air, then this gamma is actually 1.41 for air. Gamma is a thing which depends on the medium. So for air, gamma is equal to 1.41, medium dependent. And if if I say this, then the velocity is 1.41 t by rho, and when you put now, then you will get the answer 330 exactly actually. 330 or 332? 332. That's a very good approximation. If you take the normal temperature and pressure values. Okay? NTP, what is NTP? 1 atmosphere, something like that. Or 1.01 into 10 to the power 5 Pascal. Pascal ही बोलते हैं. नहीं, Newton per meter square, but Newton per एक ही होगा ना. What about the density of the air? So something like 1.29 into 10 to the power वो भी लिखा है. -3. You use these values and you will be able to get the value of speed of sound. ठीक है? So this is the motion.
Is it getting understood?
Yeah, there is a root obviously. Can't you see? There was a root. Good. ठीक है? So is there any problem here? You should always use the correction factor wala formula and then these things. So these are when the longitudinal wave is going through a fluid. What if it is going through a solid? Then what will be the value? The speed of longitudinal wave passing through a solid, and that is V is equal to y by rho. What is y called? Anybody knows?
Young's modulus.
Yes, what is the Young's modulus? चलो अब ये भी पूछ लेता हूँ. What is the y का definition? वो भी बच्चे नहीं बता पाएंगे. बताओ, what is the Young's modulus definition?
Shear stress by shear longitude
Delta by L.
It's longitudinal stress by longitudinal strain. मुश्किल है. So I am not doing anything more than this today. But can I give one question? You can take it as a homework if you want. It's a very simple question. You have written up until here? Just remember these formulas of velocities. For different waves, it's different. For different mediums as well. So, can I write the question?
Yes.
discuss this next time. Okay. That is the end of the lecture.